is when it says verify a trig identity, it's actually going to be kind of nice for you, because instead of like yesterday's homework where we just had an expression and you just had to like simplify it and see what it would come out to be, when you're verifying a trig identity, instead of an expression, it will give you an equation. So basically it's going to look like the stuff from Friday, but then there's going to be an equal sign, and it's going to tell you what it equals. It equals cosine squared of theta. And then your job is to make one side look like that. Okay? So it's basically like giving you the answer, and then you just have to do all the work to get to that answer. And that's what verifying trig identities is. So here are some things to note about verifying trig identities. The first thing, and this one's going to be hard when you start, you want to work with only one side at a time. And you should always start with the complicated side. I would say like there's a complicated side and then there's like an easy side that I kind of always view as my answer side. So I usually do most, if not all, of my work on one side. I'd say that's probably better than treating this like an equation where you're going to move things back and forth from side to side. Avoid that if possible, and just try to do work like you did on Friday. You are just going to work with that one long expression, and you're going to get it down to that simplified expression using identities and other simplifying rules. Okay. Here are some tips that you can write down, and some of them are very similar to the tips that we talked about on Friday. So you can look for factoring. Okay. So like Kirsten's example from the homework, look for that issue of like if you're adding and subtracting three separate terms, are those three terms that you could see as a trinomial that you could factor? Or look for perfect squares that you could factor, or even greatest common factors. Okay. You might also look for combining fractions. So if you have fractions that are being added or subtracted or multiplied, do that work so instead of having two separate fractions, you have one fraction. Okay, so put those together. One that we didn't really talk about last week on Friday, but is an option for you is if you have something in the denominator like 1 plus sine x. A lot of people will see 1 plus sine x and they'll think, gosh, that looks like Pythagorean identity, but then it's not sine squared. So is there a way for me to kind of manipulate that? Multiply by the conjugate on the numerator and the denominator. If you multiplied by 1 minus sine x on the top and the bottom, then when you multiply the denominator 1 plus sine x, 1 minus sine x, you're going to get 1 minus sine squared theta. And you'd be able to use Pythagorean theorem or Pythagorean identity. So that's an option for you, multiplying denominators by conjugates. That'd be when you see like plus or minus in the denominator, okay, and it doesn't fit a trig or a Pythagorean identity already. Certainly substitution with your fundamental identities. So that's all the stuff from 5.1. If you see reciprocals or quotient or Pythagorean, okay, go ahead and do those substitutions. Which kind of gets us back to what we talked about last Friday, like try to get everything in the same trig ratio. If you can't get everything in the same trig function, then try to get them all in sines and cosines. Like that's still a good method for you here. Okay, so you're really using your skills from Friday for today. And my last tip is to do something. So it seems like maybe the weekend was an issue for us in terms of our homework completion. I'm hoping that was the weekend and not like looking at the homework and saying I don't know how to do it. So I didn't have that many people come in for help. But there's no substitute for you just doing something. You've got to write down a first step and try it. And maybe it doesn't take you where you want to go, but you've at least done that first step and you've tried it. Okay. Of course, we've got to make sure that our first steps are accurate steps or appropriate steps, things that we're allowed to do. But don't ever talk yourself out of this work saying like, oh yeah, I just don't get verifying trig identities, so I'm not going to do it. because that's not going to increase your skill level at all. So there is kind of a moment in the beginning. Some of us catch on really quickly, and then some of us take a little bit longer. Don't beat yourself up. Just keep going. Keep trying. Okay, so here's my first example. You can copy that down in your notes. And this is the only example that we're going to do as a whole class. Like I said, after this, I'm going to split you up into some partners, and you will work to do some of your own problems in an activity. So we've got cosecant squared theta minus cotangent squared theta all over tangent squared theta, cosecant squared theta. Equals cosine squared theta. I am going to be a stickler on this when I'm coming around to check your homework tomorrow. Do you have reasons? I'd like to see your reasons. You only have I think 6 problems total, 4 of them required. So to do less problems and write out your reasons, I'm really wanting you to do that because I'm going to be checking that stuff on Thursday. Okay. So we want to write out our reasons. Reasons can be some of those identities from Friday, but they can also be things like add, subtract, multiply, simplify, that type of stuff. You see there are 2 sides. Do you see one side as more complicated than the other? The left side, right? Okay. So I view this cosine squared theta right there as like my answer to those problems that we would have done on Friday. So what we want to do is we want to focus on the left side. We want to do things to the left side so that it simplifies to be cosine squared theta. Okay, so I'm going to give you maybe like 20 seconds, just quietly at your desk. I want you to look at the left side and think about the work that we did on Friday. What would you think about doing? What are some options we have to start? So I'll give you 20 seconds just to think about by yourself. Okay, let's throw out some ideas. Where might we start? Trevor, what's something you thought you might do? Oh, write the cosecants out as reciprocals. So reciprocal would be 1 over sine squared. Okay. Are we okay with that idea? So I'm going to write 1 over sine squared theta minus, were you going to do anything with cotangent and tangent using reciprocals? What's that other one with tangent and cotangent?
Quotient.
Quotients. Yeah, so are you okay with me doing like 2 steps in one right here? We're going to rewrite everything using reciprocal and quotient property. So cosecant squared becomes 1 over sine squared. Cotangent becomes cosine squared theta over sine squared theta. That's my numerator. And then in my denominator, tangent squared is sine squared theta over cosine squared theta. And like Trevor said initially, that cosecant he's going to write out as 1 over sine squared theta. Okay, Trevor, thank you for doing that. Volunteering after I called on you. I appreciate that. Reciprocal and quotient identities. So if you do 2 steps in one, I think that's okay. Just, let your reason reflect that. So I'm doing 2 things, so substitution. Now, you might look at that work and think, gosh, I don't know that that made anything simpler. It almost looks worse now I have fractions in the numerator and fractions in the denominator. But the nice thing, I suppose, if you think back to all the tips, we put everything in sines and cosines. Okay, so looking at that now, Catherine, do you have any ideas where we might go from here?
Well, with the original problem, what I did was I took the numerator and I replaced it with 1 because it was
Oh, so you did it differently.
Yeah.
Okay, so we'll come back to you. Okay. We'll come back to you later. But if we're looking at what we have now, Blake, do you see anything we could do with Trevor's work? Yeah, in the numerator, you're adding and subtracting fractions, right? So you can definitely subtract those. What's really nice is they already have common denominators. So in the numerator, I'm going to get 1 minus cosine squared theta all over sine squared theta. And we could also do some combining in the denominator. Instead of adding and subtracting those, we are multiplying them. And before I multiply them, I can cross cancel, so the sine squareds are going to cancel out there, so I'm just going to have cosine squared in the denominator. So I'm going to write for my reason there, I was subtracting and multiplying fractions. Okay. Oh, you could multiply by the reciprocal, so you're saying keep the numerator and then multiply by 1 over cosine squared? Yeah, I really like what you're doing there. It's like you have an idea, but before you actually execute your idea, you still think about like what other options you have, right? Because that's part of like what we'll get better at as we work through these. We'll start to see, oh, this might actually be a better way. So in the numerator, the 1 minus cosine squared theta, that's a Pythagorean that should really stick out to us after section 5.1. 1 minus cosine squared theta is really equal to sine squared theta. And I think we could also all say, this is working out pretty nicely. Oh, I wrote this wrong, didn't I? I missed the 1 over cosine on the denominator. Did you catch that and not yell at me? When I canceled out the signs, I should have written it as 1 over cosine squared, not just cosine squared. You guys caught that? Okay, make sure you change that in your notes if you didn't. I didn't originally have that 1 over cosine squared. That's important later on. Okay. But finish off my line. Let's see, what would be my reason there? Oh yeah, David said Pythagorean identities. Okay. And you can see instantly once you ID the Pythagorean piece, what happens in the numerator? Sine over sine reduces is really just equal to 1. So there is the placeholder. Okay, there. So I have 1 over cosine squared theta. So I could just say simplify here. Okay, now we could say multiply by the reciprocal. So it's really like 1 times cosine squared over 1, which gets me to cosine squared theta equals cosine squared theta. Okay, so I'm going to say multiply by the reciprocal. And then I'll just say simplify again. You could have, like, had I caught that earlier, that 1 over cosine squared theta that I missed, I could have changed that by reciprocal identity to a secant squared. And then at the end, you would have ended up with 1 over secant squared theta, which by reciprocal identity, again, is just cosine squared theta. So there were other ways to attack that. Okay. I really like What was the beginning? Cotangent squared minus cosecant? Cosecant minus cotangent. Cosecant squared minus cotangent squared all over tangent. Tangent squared times cosecant squared. Okay, and so if we look at this from a different perspective, okay, this is what Catherine said. She was looking at the top and she saw this cosecant squared and cotangent squared. Maybe flip back in her notes and looked at all the Pythagorean identities. Everything's squared, so you're kind of looking at that anyway. And we have one Pythagorean theorem. How did we write it out? 1 plus cotangent? Okay. 1 plus cotangent squared x equals cosecant squared x. We have that Pythagorean theorem written, or Pythagorean identity written down in the notes, but we could manipulate that, subtracting a cotangent theta, or cotangent squared theta from both sides, and then we know that, like Catherine said, that numerator is equal to 1. Okay, so if we utilize Catherine's substitution there, 1 over tangent squared theta times cosecant squared theta. I'm changing the problem. So that would be Pythagorean identity. What might you do with Catherine's work that's left over now?
Use the base identities and change it to cosecant squared.
Yeah, I'll probably go back to what Trevor had done, but instead of having to change the ones in the numerator as well, we'll just be changing the ones in the denominator. So we'll have like 1 over sine squared theta over cosine squared theta times 1 over sine squared theta. And look how quickly we got to what was our like second to last step before. So this would be quotient, reciprocal, identity. We could write this as 1 over secant squared theta by reciprocal identity in the denominator. Okay, 1 over cosine, and then we have cosine squared by reciprocal again. Okay. So there's more than one way to do it. Okay, good, but I like that. You can look at it different ways. A couple of things to note about like what I want to see on your homework when I'm checking your homework tomorrow. I should see multiple steps. So most of these require, I would say, at least 2 steps in the middle. Okay, so you should have some steps shown. Notice that at each step, I keep that right side still there. So I always write equals cosine squared theta. Okay, that's part of verifying the trig identity. You keep the equation as a whole all the way down. Okay, and the other thing I'm going to be looking for when I check your homework assignments tomorrow is I'm going to be looking to see, like, did you list your reasons? And notice my reasons are very simple. In that first example that we did, we had a lot of times where, like, things were just canceling out, and I just wanted to show that step. So my description is just, like, simplify, or it could be reduce. Things like add and multiply, that's what you're doing. You should be able to write that out. Okay, so that's also acceptable. Does anybody have any questions about this example before you do your activity? Okay. On the activity, you are going to be split up into pairs.